Hello, welcome to Math 1960 section 8.2. Today we will discuss about infinite series. So after the today lecture, we should be able to determine whether a series has a sum or not. We should be able to analyze geometric series, should be able to analyze harmonic series. So what is infinite series? Infinite series is collection of infinite numbers. So like summation of s of k from k equal to 1 up to infinity. That will give you a1, a2, and so forth. So collection of these is known as infinite series. So let's consider an example of an infinite series. So say you have a square with side, the length of the side is 1 unit, so that means the area of the square would be equals to 1 square unit. So we divide the square into 2, so here we have 1/2, and this whole area is 1/2. We divide the second, this 1/2 into 1/4, and then this is all 1/4. We divide the second 1/4 into 1/8. This is all 1/8, and we divide the 1/8 again into 1/16. This is 1/16, and this is 1/16. So we divide the second 1/16 into 2. So we have 1/32, and here 1/32, and then we divide 1/32 into 2 again, and so forth. So the area of that circle remain 1, but the area of that square is equals to 1/2 plus 1/4 plus 1/8, 1/16, all the way, and on and on. So this is an infinite summation of numbers. Okay, so we're going to sum them up. This is an infinite series, but this infinite series happen to have sum. So the summation here converges to 1. So the same example, find the sequence of partial sum. We want to find partial sum of these. So S1, partial sum number 1, which is going to be equal to A1. At this point, it's going to be equals to 1/2. 1/2 is the same as 1 minus 1/2, right? And then S2 should be equals to S1 plus A2, which is 1 minus 1/2 plus 1/4. That is equal to 1 minus 1/4. S3 is equal to S2 plus A3, which is equal to 1 minus 1/4 plus 1/8, which is equal to 1 minus 1/8. And then S of n is equal to 1 minus 1 over 2 raised to power n. So to find the summation of all these, or to find whether this one here has a sum, so we can actually find limit as n goes to infinity of 1 minus 1 over n over 2 raised to power of n, and then we get 1. So the summation of these sequences converges to 1. So here we have a sum here. This sum So we want to show that it's equal to 1. So first we want to come up with some sort of a formula. So here s of 1, partial sum of number 1 is going to be equal to 1 over 1 times 2. S2 should be equals to 1 over 1 times 2 plus 1 over 2 times 3. S3 should be equals to 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4. And then S of n, now we know that it's going to be 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 all the way to 1 over n times n plus 1. Okay, so right now we're just going to take this one, which is the nth, it's more like the nth term of this. So we're going to say 1 over n plus 1. We use partial fraction decomposition and we get 1 over n minus 1 over n plus 1. This is the decomposition of this. And then using this, we should say S of n is equal to 1 over 1 minus 1 half plus 1 half plus minus 1/3, 1 over 3 plus 1/3 plus minus 1/4 plus 1/4, and then and on up to 1 over n minus 1 minus 1 over n plus 1 over n minus 1 over n plus 1. So the summation would go on and on. So then this and this cancels out, this and this cancels out, this and this cancels out, and then it goes on and on. I mean, you can do it in your paper and you will verify that S of n can be rewritten as 1 minus 1 over n plus 1. And then now to verify that this converges to 1, then we take the limit as n goes to infinity of 1 minus 1 over n plus 1. And if we take the limit of that, we get this equal to 1. So we want to show that this series diverges. Well, so S of n of this series is either going to give you -1 or it's going to give you 0. So when k is odd, it's going to give you -1. And when k is even, it's going to give you 0. So this is what you're going to get from here. That means it diverges. It doesn't come to a certain number. And then this type of series, the summation S of n can be given as k if n times n plus 1 over 2. That's S of n of this. Then if we take the limit as n goes to infinity of n plus 1 over 2, this should be equal to infinity. That means this series diverges. So harmonic series, any geometric series has this type of formula. So here I have A, which is basically a real number. And then I have r. R here is between 1 and -1. So if r is between 1 and -1, this one here is true. But if r is greater than 1, then this formula cannot be used. That means the geometric series diverges. Okay, so right now we want to find the sum of these. Well, the sum of these, if we call it S, it's going to be equals to A over 1 minus R. R here being 2 over 5, and that should be equals to 8 divided by 3 over 5. That would be equals to 40 over 3. For this one here, the sum, it's going to be equals to 1 over 1 plus 5 over 9. That would be equals to 9 over 14. And then this one here, r here is greater than 1. That means this function here diverges. This function converges, but this one here diverges because r is greater than 1. For this one here, we have to rewrite it as follows. So k equals to 1 all the way to infinity, and then we say 1/2 times 1/2 raised to the power of k minus 1. So then a here is 1/2. So here have 1 minus 1/2, then we have this is equal to 1. So we want to analyze the harmonic series. Harmonic series, any series that looks like this is known as a harmonic series. Okay, always harmonic series converges. Diverges. All the harmonic series, all of them, they diverge. All the harmonic series diverges. Okay.